Mark, Bare Naked, Willie, welcome to another Dave Cooper Live BS Friday. The weeks are just flying by, Mark. I don't know where they're going, but every day I wake up, it seems like it's another building science day.
Well, the nice thing is we get to count down how many weeks, Dave, and this is week number 49 of BS Friday Live,
49.
Dave Cooper Live.
I love it. I mean, listen, we've been at this almost a full year on this show. We've completed 52 weeks on some of our other shows, and we're going to continue to bring you the most innovative and best in our industries. As most people know, Mark, Willie, and I have come together to bring building science to you, along with the offsite construction community, to build it bigger, badder, and better home and buildings, healthier, safer, all the fun stuff. And you know what's so cool about today?
It's where you're located, Dave?
Oh, wait, this is a cool. I'm in Lake Nona at a Tavistock development. There is autonomous cars here driving our vehicles, driving people and shuttling them around. They have a teleport, which is built for flying cars, and the whole community is built around health and wellness. Even the town center's big beacon, which is a big video, is really a stethoscope. So when you see it from the airplane, it looks like a big stethoscope. So it's a really cool community, and they're doing some amazing stuff, growing plants in your house, on your walls, all of that. But that's not what I was alluding to. I was alluding to that we have an all-female team, plus one, female team plus one. You'll see the plus one. And I think that is absolutely awesome. I mean, we're going to go further, faster with these kind of minds coming together, and pretty soon I'm hoping to wear a pink hard hat.
Their hard hats are incredible.
Pink hard hat.
Yeah, their hard hats are incredible. Their skill sets are surpassing all your expectations, and the collaboration they came up with for the brilliant client that desired this project is just right. So it's a learning lesson of the digitally built projects that we love, of the offsite projects that we love, and the community-based projects that we all need.
Yeah, 100%. All right, everybody. So if you're just tuning in, Mark, and everybody else out there, we are live. Go for it, Mark, on
Facebook, LinkedIn,
YouTube,
YouTube, and
Twitch. Why are we on Twitch, Mark?
Our buddy Greg Ugaldi says that's the place to inspire youth, and we're there for that reason.
Yeah, 100%. So listen, everybody, if you are just joining us, we are bringing you the people and the places and the processes that are building it better. Our guests include experts in building systems to building science, building codes, and the tech used to build it better. And we are always seeking out the best and the brightest in construction and discovering all the ways that innovative buildings come to life. And today is no different. And we do have a special guest that's going to do an introduction today. And before that special guest comes on, because I know he knows all these people personally, we have Silvergreen is an all-electric, carbon-smart, vapor-open, custom site built in prefab Theus plus pre-certified multifamily passive house. And they have used offsite construction as one of their solutions during this, Blueprint Robotics. And they've been using world-class suppliers like Mitsubishi Electric, Zender America, Zola Windows, Doors, and Styco and Ream. I mean, this is going to be a great show, Mark. I mean, they're using companies that believe in what's happening in our world of building science. And I think this is going to be amazing.
It's a shared voice. It's a culmination of the manufacturers, the know-how, and how to put it together. Strap on your seatbelts, put your tray in the full upright position. Crash helmets are not needed because this is safe and healthy.
Love it. All right, so why don't we bring in somebody who has been on this show several times, doing several intros. Sean, what's up, Sean?
How you guys doing?
Good, how you doing?
I know you love prefab, so I'm on a prefab job site here in Kelowna, BC, and I'm sorry, I didn't use the helicopter. I had my brand new PH 150 get me here nice and safe this morning. And again, we're talking prefab, we're talking high performance, we're talking vapor open, low embodied carbon products. And this particular project behind me is done by Collector Carpentry. And what's nice about this one is all about collaboration. And the guests you have on are even more about collaboration. And Mark, I think this is a word that either our friend Mike Ingwe or maybe his son Dylan has been using a lot this week. And it's a great word because the 3 people you have on, and I'll talk about the female crew first, because this project that you're about to see is like no other. And I hope people get inspired from it, because this is how we should be building, constructing, designing, and working through our future projects. Because, and again, Dave, you've talked about this on other shows you have, is the digital twin. That model of designing it before it gets built, to review collisions, review details, to then give it out to shop drawings, a great tool. And so Shannon, Elka, Angela, and you got a bonus one with Steve, because Steve and Elka are going to talk about the Holtzrem systems that they've created, which is an amazing tool and really should be used. And people really need to look at that whole digital twin modeling before you build, because it saves on time, saves on resources, and really allows for some great discussions with the clients before you get under construction. So from this lovely prefab house here in Kelowna, BC, to going over to the East Coast, take it away, you guys. Great show, and thanks for having me.
Hey, Sean, thanks for joining us, and we're gonna bring in those guests. Sean, are you gonna stick around today? Or are we gonna have you back at the end?
I'm gonna put on mute, and I'm gonna give you guys a bit of a tour, and then we got to finish some air sealing. But just think about this. This project had a concrete slab on it on Monday. It's Friday, and they're just finishing up the air sealing, and it's done. The exterior fun elements, like all the aesthetic stuff, is going to get attached to the box. But again, simple design. It's going to look good once it's all finished. But think about it. In 1 week, it went from slab to insulated, weather barrier, air barrier, structural components. It's all done, and the builder is going to take over on Monday.
What panelization system is that, Sean?
So this is done by Collector Carpentry, using, again, 475s Proclima membranes, where, again, plywood on the inside, I-joist filled with cellulose, a membrane on the outside. So, again, the wood that's been in here has never really seen the outside. It went from sawmill, factory, site, wrapped, dried. Can't say more about it.
Love it.
It's great.
Perfect.
The only time the wood's been outside is when it spent all those wonderful years growing. Right? From dirt to sunlight. Sean, it's great to have Dave in Florida. You're up in Kelowna. The live forecast and the introduction to our friends. If you can pop in later, join us, and let's roll it.
That's it. All right, Sean, we appreciate you, man. Take care. All right, Mark. So listen, let's hop into this. We got a lot to cover today, and I really, really want to jump into this. We have the power of 3+1, I think is kind of how Sean said it. So why don't we bring all of them into the show and really lean into what they have done, because they are in Pennsylvania, right outside of Pennsylvania, Philadelphia. Even though I'm from Pittsburgh, I won't hold that against them. Let's bring them in one by one here.
Angela, Ilka, Shannon, Steve, welcome this morning, and thank you, Sean.
Yeah. This is awesome.
Oh, my hat.
Listen, so first of all, I want to say that I love the Think hats, right? Spelled with a PH, Think. I love the Think hats. Look, Mark's turning red. He loves it. I love it. But here's the thing that I find most impressive about what all of you have done on this, and I'm just looking to make sure. We need more women in construction. Okay. We need more women in construction. You guys have done an amazing project. I've looked at your deck. I've looked at the plans. I have looked at the detail that has gone into those plans, and I'm telling you, a lot of people have a lot to learn from what you four have done. So I just wanted to say congratulations to that. We review this stuff all the time. I have been in the offsite industry for a long time, and what you have done is, in my opinion, outstanding, amazing, and I'm looking forward to celebrating it today.
Wow, that is a great introduction. I'll take all the credit. No, of course, it's a huge effort. Oh my gosh, it's not any one of the three of us. It's not just the three of us together. It's the whole team. We had a huge team. It was amazing. But like you said, everybody's heart was in the right place. So I'm excited to be here. Thank you, Dave. Thank you, Mark. Thank you, Steve, for jumping in with the girls today. And thanks to Sean if you're listening out there. And good luck on that project. That I want to know more about that too. That's exciting.
Yeah. And put some sunscreen on, Sean, because it looks like it's sunny out there. We want to make sure you have clean, healthy skin for a long time. All right. That's my health note. So listen, we do this on every show, and I think today's going to be a lot of fun. We want to know everything about each and every one of you from the moment you were born to this very moment in time. And if you don't tell us everything, Mark Willie will call your mothers, and you all know that there is no saying no to Mark, and he'll find out things you probably don't want him to know. But guess what? You only have 2 minutes each to do it. Shannon, why don't we start off with you?
Well, great, thank you. So yes, there was a moment where I was not on the planet, and then all of a sudden I was. Here I came. But I loved a lot of things growing up. I didn't know what I wanted to be. So for all you kids out there trying to figure it out, just follow what you love. That was the best advice I ever got. And when I went away to school, I got a little disillusioned, a little mad at the world, didn't like the way people were treating the planet, and eventually found architecture. And it hit me like a ton of bricks, and I fell in love with it. So I drove into that, like, to the head of steam, and then became a little disillusioned with the profession because it wasn't moving fast enough towards sustainability. And I'm going to date myself. I remember when we had to draw curves out of straight lines in AutoCAD. I was in the first digital studio at Temple University, and the teachers did not like it that we weren't going to use paper anymore. So that's how old I am. But long story short, being able to prove it is what drew me to Passive House. And when I was talking sustainability with my old school builder friends and the people that taught me coming up how to draw better so they could build better, now I'm teaching them. I'm turning it around a little bit. But without Passive House, without building science, you can't prove it. You're hugging a tree, and it's nice to hug a tree, but we can do better. We can prove it now.
Yeah. I mean, you're so right on that. I mean, the data is there now. The proof is in the pudding, and people are doing it just like you. I love it. All right, Ilka, here we go. You got your 2 minutes. Go for it.
Okay, so 2 minutes shouldn't be a problem for me because I'm from Germany and we don't, we're pretty much to the point.
Ich spreche ein bisschen Deutsch, ja?
Yeah, ich spreche Deutsch. I was born in Germany a while back too, by now. And I started architecture school at in Aachen at a technical university. And I guess kind of knew about Passive House back then, but I wasn't really there to really just kind of get into it and actually study it. I was fortunate enough to be an exchange student and going to the University of Washington in Seattle. And then I was even more fortunate to actually do an internship at Olsen Kundig for a year and a half. I came back, finished my degree in Germany, but ended up being married to an American architect. And we moved back here to Philadelphia and started an architecture firm. And I was just trying to specialize more and more on Passive House. By then it was more known. And things weren't really moving fast enough for me either. So I started working with Steve on high performance buildings and passive houses. And eventually we actually started Holzraum System. I am passionate about bringing more women into the construction field. I feel like prefabrication is a really, really good way to do that. Hope that I'll be able to work with more women in the future. That's it.
Dave, you're on mute.
Look at that. So I don't think it's a hope. I think it's a guarantee that we're going to have more women in the construction space. And I also believe that once we launch this women's safety line of clothing and safety gear, it's going to even really go through the roof, right? With our Fink hats. I'm going to play up this Fink hat all day long. I love it.
Especially if you call the brand Fink, right? Perfect.
Yeah, I love it. I love it. All right, listen, Steve, why don't you do the follow-up to that? And then Angela, we'll round it out with yourself. And then we're going to hop into this awesome presentation that you all have. And remember, if you're just joining us and you have a question during this presentation, please put a Q in front of it, because there's a lot to banter that always happens, which we love, but it helps us identify the question. All right, let's do it, Angela. Or I'm sorry, Steve, you are up.
Okay, so I actually started in a strange place. I graduated with a communications degree from Penn State in the 90s and was drawn towards carpentry and saw some things some friends of mine were doing with restoration of old barns and historical preservation. So I actually did a 5-year apprenticeship as a as a restoration carpenter. And then I got plucked out of that. Somebody asked me, they knew I was getting into some CAD design early on, just sort of self-taught in the beginning. And they were starting up the first 5-axis CNC plant for timber framing in the country. And so they asked me to join that firm, and I did, and started out as a machine operator and programmer, and then worked my way into design, and then eventually led their design department. And we built some really awesome projects, including like 100-foot span trusses from heavy timber and structural glue lam. And then got back into the field and was kind of like marrying my love for 3D modeling and also carpentry, and eventually ended up with a really great timber framing company where I was back sort of in the design seat. And that's when I found out about Passive House in 2000, and I guess the end of 2014, and became a CPHC in 2015. And kind of everything changed, and I've never really been the same since. So by that time, I had pretty good idea about the best way for me to use 3D modeling to kind of construction manage what we were doing. So I led their construction management department for Passive House and high performance buildings. And then started working with Ilka and C2, and we started doing a few Passive House projects together without panels. And then eventually Ilka and I found Blueprint Robotics and decided to sell our clients on full panelization with floors, roofs, and brought foam-free assemblies to them and developed our current wall assemblies and roof assemblies. And then just kind of started Holstrom System because we thought there was a big need to kind of bridge the gap between the individual components in a system that would really kind of encompass a coordinated model.
I love it. I love it. All right. Awesome. Angela, you are the anchor. You're bringing up the rear on this, which I think is great because I have a feeling you're going to lead us into a great presentation after we learn a little bit about yourself. So hop right into it.
Awesome. Thank you guys so much for having us. So let's see. So how did I get here and what am I doing now? So I studied architecture undergrad, and I remember second semester of my senior year, I had already gotten into grad school for architecture. I was ready to go, and I was like touring these different places and talking to professionals. And I realized that a lot of architects didn't necessarily care about sustainability. And it wasn't just that, it was a couple things, but I kind of had this epiphany and I was like, I don't want to be an architect. Like, I want to be more boots on the ground and really be in the details of energy management and higher performing buildings. So I kind of switched to the dark side and studied engineering and started working for a firm doing HVAC and enclosure commissioning, which was completely eye-opening for me because I saw firsthand how and why our buildings consume so much energy, and it's mostly because things get built and no one checks anything. So that really kind of motivated me to get more involved in everything sustainability related, and ultimately Passive House. How can we kind of improve our approach to buildings, and what are all of the things that we're not doing that we need to be doing. And one of my favorite sayings that I stole from ILFI is it's not good enough to just do less bad, right? We need to start doing more good. And Passive House is definitely an avenue for that. So yeah. So I'm also currently the co-chair of the Passive House community in the Philly and Delaware Valley region. So if we have any listeners listening in now who want to get more involved, please reach out to us. I actually took over for Shannon. So we always love new, enthusiastic Passive House people.
I love the Dave.
I love it. I don't hear any enthusiasm.
I love the invitation too for people to get involved, because that's how we truly grow the community. I'm sure you donate your time, as do many other amazing professionals, for that to happen. And that environment is creating our future environment. So bless your hearts.
Yeah, it truly is, and I agree with Mark. All right, so we have a presentation to go through today, and this is a presentation that you have shared with the Passive House community before as well. So it's really up to you on how you want to go about this, but I'd be willing to bet in this presentation there's some favorite parts of it that you love to talk about as well. So however you guys want to go, you just let me know. We'll put it up on the screen. But I think sharing the most important parts and getting our audience engaged, we're going to go for about 10 minutes. And we'll bring the audience in. But the show is yours. You guys ready for the presentation?
Absolutely.
Fast forward. Let's do it.
Rock on.
All right. I can see it. Can you see it?
Yep, we're good.
Okay, great. Well, thanks again for having us. I love hearing the intros, especially Angela going to the dark side. That's good stuff. So if you can see my screen, before we talk about the project, I want to talk about how we all met. And if you're just getting into green building, it's a great idea to volunteer at your local green building place. So we're all part of Green Building United in Philly. Here's Steve and Ilka on the top right doing it for free. There's Angela on the left doing it for free. We like to have a good time and talk building science, just like you guys. So this is just a little comment before we talk about the project, because we're going to talk about a legacy project, right? It's a real beautiful, unique opportunity that comes around kind of once in a lifetime. But what we're all passionate about is doing it affordably, right? And being women in the field, we want to give back to our communities. We want to make sure that 90% of the income goes back into the community and into the families. So with that, that's my favorite quote. When women work, they do invest that much back in. So it's a good reason to have a girl around. And now we'll talk a little bit about the project. So this is Silvergreen. I'm Shannon Pendleton, designer, Passive House consultant, Sanderson Design, on the East Coast in New Hope, PA. And Silvergreen is about 30 minutes away from me. And it's a Passive House. So we're going to explore how we got here, why Passive House, and then why prefabricate, because we chose prefabrication. It was the first time for me. And there's some lessons learned to share so that you can do it too. So we'll look at how those two choices changed our process and solve coordination challenges, and what we'd repeat or improve for next time. So basically, our client asked us to design time and gave us the opportunity to marry a number of opposites. She wanted the house to look old, think new, prepare for the future, bring her community together, and celebrate its past, and be an example for its future. So Silvergreen is 2 dwellings with a shared garage, a large community event space. It's all electric. We took out the gas meter, and it's pre-certified 2018 plus right now. We're about 4 months from completion and about 10,000 square feet for everything. And behind every great team is a great owner. So there's Susan on the top left, and Revision in the middle. Angela's in there. Some great team members there. And then everybody on the right are folks who were either at the factory when we were checking out the panelization, It was so clean you could eat off the floor. And then a lot of the folks putting it together in the field, including Susan's mom, who was one of our inspirations for aging in place. So we were about 50% passive house experts and 50% first timers. But our experience was heavy on the design side. So we chose prefab to keep the hard build parts easy, the wall assemblies and the window installations. So we did it right. We did the IPD thing, right? We got the team together early, but look at all these charts that people use to talk about IPD. There's nobody in the middle. If you can see my mouse, there's nobody home in the middle here. Who's in the middle here? And what happens between these three folks in the middle here? And then we totally forgot to include the robots. We're dealing with robots now, right? Where do they fit in the process?
Shannon, let me ask you a quick question. Can you just explain to our audience what IPD means? Because we're bringing two communities together here, and I think that would be very important for them to understand.
Right, so integrated project delivery. It means you assemble all the team players early, right? So if you want to take it down to just two, if you're an architect and you're drawing for a builder, it's great to have the builder around because you can call them and say, I'm drawing this detail, how do you want it built? Because there's no point in drawing it if you don't want to build it that way. And the two of us figuring it out together saves time and makes a better product. Well, the same applies for the whole team. But if you get the whole team together and you haven't been through something before, then you have to have the right team so you can get there together and invent the race car while you're racing the Indy 500, which is some of what we did. We knew what we were doing, but there was some new stuff. These robots, they were new. So let's talk about where we're located. We're in Bernathen, PA, and we're on a steepish slope. We're between Philly and Trenton, New Jersey, alongside a National Historic Landmark District and the Pennypack Ecological Land Trust. So our design priorities were for two sustainable homes that would fit with the community now and rent affordably now and renovate in 20 years for aging in place when the owner wanted to move in. And we needed space for big family gatherings, a future accessible space for community events and fundraisers. And if you look at these pictures, our oldest living residents on the site were the natural spring, the spring house, the wetland, and a 300-year-old buttonwood tree. And we also inherited a sentimental rental up there on the upper left, known as the Bishop King house, that we had to take down. We tried to save it, but it just wasn't enough to save, unfortunately. So we also inherited the history of Bernathen, which was actually founded and planned on our site, which is in the top center back in the day. And luckily, the 4 windmill foundation stones are still there, and they supplied the community water supply. So it's pretty poetic. So we talked to Susan, we determined our level of green, talked about the importance of certification, and gave her a crash course. And she chose Passive House. She's like, if we're going to do this, we're going to get the highest efficiency, the best comfort, and we're going to do it through passive means, conservation first. You don't even need renewables. You get 80 to 90% of the way to zero. No renewables, right? Just building it better. And then using living building as our guide, right? It's harder to achieve. It can be a little more expensive sometimes, in my opinion. I'd love to be proven wrong there. But it helps with materials, with water, with site, with equity, and with health. So we were certifying Passive House, but we were referencing living building a lot for our products so that everything could be carbon smart and healthy. So we determined our strategy and did some site planning for protecting our natural features. Looked at our solar exposure so we could do natural lighting and power potential. And we were aware of our position at the top of the watershed. And Think Green did this beautiful drawing. They basically drew up a series of strategies so that we could infiltrate all our stormwater, even during heavy events, over a series of days, just through gravity and rain gardens. And it flows through these destinations and past our windmill stones. So they were terrific. And our space planning strategy was secure the envelope, right? So a lot of people say secure the bag. if you secure the envelope, you've secured the bag. We wanted to make sure that she wasn't ever going to have to change the footprint or change the facade, and that it would fit in beautifully. But we would plan in this 20-year renovation so that she could move bedrooms up and down over 20 years, knock out walls, put in elevators, and finish the event space in the future. So a big part of phase one was defining our envelope to be airtight, super insulated, and thermal bridge free. So if you're familiar with Passive House, this will look familiar. It meant selecting roof, floor, and wall assemblies, testing them for accuracy and performance to make sure that they were going to stay dry, weren't going to grow mold, and that we could size the right systems for something so efficient. And here is our system strategy. So the good news here is we can swap out any mechanicals or improve on any mechanicals over time as warranties end or a new technology shows up without poking any new holes in that beautiful building envelope, that Passive House envelope. And our system strategy for the main house, our mechanical room's right down here. Here's a photo of it. And here's what's outside. It's just a couple pieces of equipment because it's so efficient, right? We've got 2 heat pumps and an outdoor condenser for those and an ERV energy recovery ventilator. And then we picked really smart appliances, heat pump, hot water heaters, induction cooktops, heat pump dryers, and stuff like that. Made sure our CFMs on our range hoods were low. For the caretaker, it looks pretty much the same. We have a little smaller mechanical room over here, and we have a heat pump in there, Zender ERV, a condenser outside, and then a little cassette for the garage, because the garage is outside the Passive House envelope, so we're just going to do a little semi-conditioning there. For power, we are going for FIAS 2018 plus, which means we need renewable energy credits now if we're not going to use solar panels to be fossil fuel free. So that's what we're doing. We're fossil fuel free, but we're still buying our energy, right? We're buying it through renewable energy credits. But we've prepped for the future. So we've got conduit to the roof. We've got a fully recyclable roof. And when Tesla finally gets around to returning our phone calls, because we've been on their list for years, we'll get those beautiful roof tiles and put them on and plug them in. And then we'll put the batteries right over here. We've already got our solar disconnect. We've got our spaces set up, and we're ready to go. We've got our car chargers installed. And so let's talk about the envelope.
Give me 1 second, Shannon.
Yeah.
Can you hear me?
I can.
So come back to the screen. I want to take a moment because we want to say hi to some of the people in our audience for one, and we got through the mechanicals. But before we do that, because I want to try and get the audience a little engaged in this as we go through, you know, I understand the why, like I get it. That was an awesome explanation. But let's talk about some of the systems or techniques that you used a little more specifically. And were there any surprise learnings out of this process, right? Because you're taking you're building in you're putting in panelization with Blueprint Robotics, one of the a highly robotic plant. And as you showed the envelope and you're showing the mechanicals, is there anything in that you'd like to share with us that was like, how did you do it? How did you pull all those pieces together? And then also, did you learn something you weren't expecting?
Absolutely. And that's what these last slides are about. But what's better is what I don't have in those slides that Angela and Ilka are going to go over, because doing the testing and verifying for this, she's going to show not only what we had to work on, but how we fixed it and how we got to where we wanted to go.
I love it.
The dynamic part that I saw is the creation of the envelope and that, as you called it, I believe, future proofing.
Yeah.
So this building is set up. I don't know if everyone heard this. This is the first time I've seen this presentation. The details are so well laid out that in 20 years, this building will create a second life. No penetrations will happen. There will be no facade changes. All those sort of external legacy things are kept in place. But then there's going to be a new use for the building. It's intended for that. But keep in mind, maybe someday this will go to someone else's hands, and they can also take on that other life. We
That's right.
won't be around, right? That this building is set up for that kind of future. Maybe it's the owner's kids or grandkids at that point, but or the community. It's just
It's
brilliant
both.
the
It is.
process it's going to take on.
Yeah, it is brilliant. And all right, so listen, Mark, I want to go to comments. And like we were saying before, in the upcoming slides, let's talk about that's what we're going to be getting into is the why and the learnings. And maybe I didn't say it the right way when I stopped you, but we definitely want to stop and say hello to some of the people that are attending today because they're taking time out of their workday to spend it with us. And then we'll get back into the learnings and the whys. How's that sound?
Perfect.
It sounds good.
All right, Jody Genghis. Hello, Kevin D. Brown. I think it's noon central. Oh, they're sharing. See, this is what's fun. We got somebody on Twitch that's saying love tour. I don't know what that means, but I'm in. I love, and touring sounds cool too. I'm living in a motorhome right now, so I'm all on board with that. We have another special guest joining us from Twitch today. Don't give it away, Mr. Mark Willie. Not just yet, but we didn't ask. Why do we go live on Twitch, Mark?
All the cool kids, which means cool is the new generation, right? The people that we're out there sharing for. They're on
That's right.
Twitch, and they're going to be building our homes and taking care of the ones that we built.
That's right.
Speaking of special guests, Angela, would you like to introduce the special guest that just left?
Well, of course, I was going to say, Mark, of course he just jumped off. That is Baloo. I apologize for having to hop off earlier briefly.
No.
He was being particularly needy. He's
Very
a
handsome.
5-month-old puppy, so
Well, you know what? Bring
he
the
might make
puppies
his way
along.
back. Yeah.
Puppies are welcome in our show. We love them. So whatever.
Perfect.
I love it. Bring them back in or her back in.
Perfect.
Does the
Right.
puppy have a name?
His name is Baloo.
Baloo.
Yes.
Baloo.
Yes.
All right. Well,
I love
Baloo, you're welcome back anytime, brother.
Baloo.
Yeah, for
I
sure.
don't know where he
Well,
went, but-
we are live on Twitch because that's where the young people are. They're not coming to us, so we've decided on our show that we're going to them, and we keep getting more and more people, and we get some surprise guests from Twitch every once in a while. All right, let's keep saying hello to some folks real quick. We got Andrew Seeley ending the week with good friends. Hey, Andrew, I hope all is well. Andrew, we were just talking. We might see you in Austin within the next week or two. We got some things going on. Just a possibility. I might have to come out there and stay in one of your G-Pods, my friend. Love it. Love it. Love it. All right. Here's the Twitch surprise. Greg Ugaldi, right on, Mark and Dave. If you do not know who Greg is the immediate past chair of NAHB. He is the top dog, as I like to say. And he's fortunate enough that he actually gets to go and give updates to the president a couple times a year. So we always love it when Greg joins, and he's been a big supporter of our show. And look at him. He's on Twitch. He's going where the young people are. We need more leaders like that. We got Scott Farman. Happy Friday, everybody. We love it, love it, love it. All right, let's get back into what we have going on here. We'll get back into the presentation. And if you have questions or you want to know specifics about this project, now in this day is the time to ask those questions, because all four of these folks that are on here, I'm sure, are very busy throughout the regular day. So let's get into it. Let's ask them questions. Let's talk about building science. Let's talk about house wrap and air tightness and healthy breathing and all those fun things. But first, let's get back to the lessons learned, what they've been doing, and how they've been doing it. Sound good? All right, Shannon, back to you on the presentation, envelope strategy.
Envelope strategy. Well, I'm just going to shout out to Scott Farman and say hi. I'm glad he's here. And everybody else, yeah, put your questions in the chat. We're sticking around. So I'll be fast through these because I want to give everybody else time. And basically, we had to marry old world craft with new building science. So everyone knows what a rain screen is. And everybody knows that we prefab part of this. So everything blue up top is prefab. Everything underneath is like a Nudura ICF. And what we did was we started on the base with these, opened them up, put some concrete in. And then we prefabbed all the walls on the first floor, brought in the floor decks, brought our air barriers around, brought in the panels on top of those, and the roof trusses on top of those. And I'll talk more about what swapped out on the inside in a minute. But the one thing that swapped out on the outside of the new Duras was you ordered a little extra insulation. We ordered the inserts. So if you look at this section, you can see there's insulation in the service cavity. Well, by bringing those inserts in and putting a little more insulation under the slab, we took that out. So now it's even easier to renovate in the future. And on the inside, we've got that air barrier coming up from underneath the slab, which we taped onto the new Dura. What I would do differently there is put our liquid air barrier on there to plug the little holes. I wouldn't change anything that we did with the holes drum package. That came in perfectly. We had no discrepancies in the measurements because the team was so amazing during coordination. And then with the ceiling, I love my Sega air barrier, but I wish I'd gone with plywood just because we popped some holes in that while we were putting it up. And we also had a groin vault arch ceiling that we had to put in. And the sequencing there was a little tough. So I think next time I'd go with plywood there. And then we also chased some air leaks at the ADA door thresholds and at one of the ERV outlets because it was hidden under the stair and didn't get air sealed before it went in. And I also would have coordinated with the subcontractors earlier. I tried, I called them. So if you're a subcontractor out there, just show up earlier because the digital twin that we create is down to the stud. And you'll get to see exactly what we have planned. And if you want to change it, that's the time to change it, not in the field anymore. Become part of the team earlier. And then here's what we did. On the left, it's our passive house verification tasks and prefab challenges, right? What was different? We had northern views, we had wood burning fireplaces. It's a very boutique house and it's an amazing project. But on the right, if you're a designer and you want to do prefab, look at everything red on this list. This is what you have to plan in sooner. Just back your whole workflow up one stage. Make construction administration, construction documents. Make construction documents, design development. Make design development, schematic design. Just back it all up and get everybody on board because you're going to do shop drawing review, early drawings package release, and a window and door order before your construction documents are done. But what you're going to have is a knowledge of how everything goes together. You're not going to have substitutions in the field because it's going to show up with the materials you specify down to the FSC woods and the carbon smart insulation. And so you're going to have less weather and less change orders. And everybody loves that. So plan for a couple extra blower door tests too. You might need those. We sure did, even with all this planning. So with that, I'm going to hand it off to Ilka, and she's going to talk about that digital twin. And then Angela's going to talk about the verification and where we made our repairs.
Yeah, so I guess I'm just going to keep it brief too, because I know that Steve is actually waiting there with the digital twin that we generated for this. But but what I was going to talk, or am going to talk about, is just more of the coordination that it takes to get to these highly customized prefabricated panels, because this is not just kind of a square kind of home that gets replicated like 100 times. This is a very, very customized, very complicated building that we had to figure out how to make basically a passive house kit out of that gets delivered on site and that actually has to all fit together. And it also has to interact with what's already there and all the other things that also have to fit in and are offsite prefabricated as well. So this is just really quickly the assembly that we used, since this was not only a passive house, but also follows principles, as Shannon said, of the Living Building Challenge. This is a panel that is vapor open, airtight, and only uses, it's foam free. It only uses wood-based components. So just kind of talking quickly about us. We are not a panel manufacturer. It's Steve and I, and then also David Hessler, who is actually a biologist and a software developer. So we kind of have a lot of different perspectives looking at this, which is, I guess, a little unusual. So since we are not a panel manufacturer, we actually take the role of coordinators and translators into what will be fabricated. So we actually work with different manufacturing partners, which led us to develop a communication strategy that is kind of universal in terms of outputs for manufacturers, as well as a tool that communicates and collaborates with all stakeholders. So we call that a single integrated manufacturing model, or SIM. So if you, next slide, Shannon. So yeah, that's kind of looking at the SIM really quickly. So, and I guess what's really important to mention that in every case, as soon as you go with prefabrication, every component has to be modeled. So a translation from a design intent, in this case we got it from Shannon in form of a Revit model, has to be so everything has to be translated into a parts-based model. And the outputs from a design intent or a volumetric model into and a parts-based model are very different, and we'll see that shortly. So, and for us using this by generating this parts-based model, that also means that there's great potential in using that further, not only for the fabrication, but only for communication with all the other trades and through the design process with everyone who's involved. So everyone becomes a part of it, and the SIM model actually becomes a tool for communication, a very visual tool for communication. So next slide. So here we were able to do clash detection with MEP and coordination with concrete, steel, roof trusses, and other prefabricated components within this single high fidelity model. Because we have the exact locations and dimensions of everything, and because we know that the robots are going to build it exactly the way we drew it, we have the chance to actually generate drawings and hand them back out to other people involved. And here you can see that we could generate a steel coordination drawing and provide 3D drawings to other fabricators like this Groin Vault. Next slide. And then the same model is actually used to generate outputs. So in this case, we worked with Blueprint Robotics. So it's data, it's machine files, but we also generate reference drawings, reference panel drawings, and that's kind of what it looks like. Next slide. And this is kind of what that looks like in action. So these are the files in action, and then actually our wall drawing there is pinned to this wall, and everything worked out perfectly in the factory. This arched window was kind of a challenge, but it all fit together. So that was great. Next slide. And then again, out of the same model, we generate documentation for the installer. So in this case, the installer was not the fabricator. So we had to make sure that the installer also got all the information that they need with panel sequencing and installation drawings. Next slide. And this is, again, what it looked like on site. Sequencing is also very important for passive house because membrane leaders have to go in at certain points during the construction. So we're able to kind of communicate that early on too. And then this little beautiful groin vault there fit perfectly as well. Next slide. And then one last thing that I want to mention is, so as soon here in Pennsylvania, as soon as you move into fabricating closed walls, that means you can't really see the structure and the insulation in the walls. It's considered a closed wall, and it calls for a third-party review. It falls under the Industrialized Housing Program here in Pennsylvania, and that is kind of very, very rigorous. And it's set up for modular housing, and it doesn't all make sense for just panels where there's nothing really in it besides the structure. So, and we wanted to mention that because we do see that as a challenge, especially as more and more smaller manufacturers come online because they're, because of this whole process. And yeah, talking about third-party review, that's kind of what Angela was for, or what she was doing, then continuing with the Passive House certification.
I love it.
Go ahead, Dave.
Are we at the end of the slide?
Yeah, my part, yes. Now it's Angela's turn.
I love it. Why don't, before we jump back in, Angela, we have some comments that have come through and some questions. Mark, you want to jump to those for a few moments?
I do. I want to ask Ilka a question first. She touched on something really great. So you had you had so many great things. The first I'll comment on is the design aspect of having the groin vault in an air-controlled space with tremendous volume is something that's hard to produce a groin vault in any structure. Secondly, the massive size of that groin vault, the volume has to be a huge number. So hats off to everyone from design to execution and 1,000 points in between. And then that comment you said was wonderful, that because of how the assemblies were put together, it qualified as an industrialized third-party review. And you said it met some challenges.
Mm-hmm.
I'm sure we could talk for about 4 to 6 weeks on those challenges, but can you answer, what did the people that reviewed that wall, what did they say that they learned from the process and the different membranes and the thickness of the wall and how you filled it and how you layered it? There had to be some aha moments that they loved.
Yeah. I don't think they really looked at that way. They're not really Passive House specific in that way. They're just very much, okay, third-party review. This is the process that we have to go through, and mainly they're looking at the structure. So they just want to make sure that the house doesn't fall apart, right? Well, so what's challenging though is that since this is the Industrialized Housing Agency is set up for modular housing, or that's the way I understand it, and the way, and I totally understand that all the rigorous reviews and everything perfectly makes sense because everything's in the walls or in these modules, everything from electricity to plumbing to everything. And they just want to make sure, because the moment they review and they sign off, it kind of takes everything off the township. So the township that supersedes the township stamp, more or less. So they just kind of deliver an already approved building. So they really look at everything, and we had to provide everything down to calculations from our engineer of record, which they typically would never ever have to do for a regular permit. So our challenge was we don't really have anything in the walls, because all of the electricity, everything happened in the service cavity, which was totally visible to everyone. So the only thing, sorry.
No, go ahead, Ilka. I didn't mean to cut you off.
Yeah, so I just wanted to finish. The only thing that was atypical for a regular inspection is that the inspector couldn't go on site and see the structural members or the insulation.
Yeah.
So from our perspective, and we tried this to argue that way, is so why don't we send a third-party reviewer, an engineer, to the factory to just kind of look at these structural members. They have all the information beforehand. They know exactly what they're looking at. They can communicate with the engineer and say, this is the panel I want to see. They can communicate with the factory, and then they can take pictures. They can do whatever they want, and they can put a stamp on saying, okay, we approve this structure. And we kind of believe that should it kind of makes sense that they could take part of an on-site framing inspection. But it's kind of right now, as soon as the panel is closed, it automatically goes down that route, and there is no way out. And we definitely see that as a challenge.
Yeah, I've being a modular builder for 20 years prior to doing this NTA, I'm almost surprised to see that they even tackled that project with you, for one. And two, you're right. Once it leaves the factory, they typically want to wash their hands of it. They're not looking to have people in the field. My question is this, because with the building inspectors in the field and with you using different systems, right? How did NTA put all those systems together to then be willing to sign off on something that wasn't built in the manufacturer? Because it was the pieces, the components were, but it was assembled on site. So they had an inspector that would have to come out there, and it's good that you were in PA, because a lot of those are in PA, these inspection agencies. But two, what I want to learn before we get into the comments is, how was it working with the local building inspectors and understanding the code on where their job begins and their job ends? Because there's a whole lot of interpretation that they have to do, because there's not a clear code that would specify what you guys have done.
So to answer your first question, it's all about a checklist on the cover page, where everyone protects themselves. It's very clear who has to check what and who's responsible for what. And with NTA, they, for us, they're fine, good to work with. They were also already engaged with Blueprint Robotics, because the thing is that not only a project has to be approved, the factory has to be approved. So the whole factory has to go through a very rigorous kind of quality assurance process to be approved. So that's the first step. And then the whole project needs to be approved. And yeah, in terms of who's responsible for what, it's really just kind of dependent on basically what the industrialized housing program dictates. It's actually not up to NTA even, and we just ran into that with another project, where things that we're able to do with Silvergreen, we're actually not able to do with this next one, although it's all in Pennsylvania, just because the industrialized housing program decided that no, this time we need to show electrical drawings and outlets and everything, although has nothing to do with the panels at all. And the second question about the townships. So I think it really depends on who is responsible. There are some townships that are a lot more open and lenient, and happy to talk to us really early in the process. So we try to make a point. We actually have a wall sample that we would take to whoever is willing to talk to us, and kind of explain the assembly, explain the process. And so far, we've only had one township that didn't even really want to talk to us until they had a permit application on their table. And by that time, it was almost too late to really get them on board. So they're very, very strict about, okay, we're not going to sign anything unless it's approved by NTA or the Industrialized Housing Agency. So it really depends.
So, Ilka, what that means is we need a panel discussion on the different processes and how to create repeatability in our panel third-party review. I think the reason all these different townships and organizations are different is because we were never aligned to be together. We only built local. And so now that we're having all this cross graining and collaborative component driving, someone needs to come forward with a white paper to provide those answers so that we don't have silos repeating this process throughout. And I believe these reviewers will also benefit from that because they're stretched with their workload and everything too. And if there's inspectors on the line, I urge you, when you're there to review the structural connections, right, because that's your job, please also ask those questions of the great things that's going on and go back and share that with your team, because these type of projects don't come across everyone's desk. And the more you share, the more our voices are heard. 6 people create a bigger megaphone than one of us on the corner.
Yeah, and that's kind of why I wanted to bring this up, because I feel there's a huge need. And also, I think for me, it's just kind of differentiating between a panel and a module. I think that's the biggest thing, that it's very different.
It is. And, and you used a term that a lot of people don't use, they're starting to use, right? Industrialized housing. We have a whole nomenclature, wording issue, definition issue. Who are we? What category do you fall in? We don't even know in our industry. And to make it very simple, I say, is it offsite with a hyphen or is it offsite without a hyphen? Is it volumetric? Is it modular? What is modular? What is volumetric? What is panelized? What's a closed system? What's an open system? Like the car industry or the computer industry, they very clearly define what verticals they're in and what they sell, right? We're working through that. So I find it very interesting that you said industrialized housing versus a panelized system. So awesome. So let's get into some of the comments and questions and say hello to a few more people. That sound like a good plan? All right, here we go. We are going to kick Buzz Holitzer's in the house. Every time I say his name, Mark, I feel like he's hopping into the boxing ring or something.
I call him the buzzard. So Buzz, I don't know if you're in Florida trying to find Dave so you guys could go scuba diving, or if you're up in Michigan, but happy Friday to you, my friend.
Yeah, for sure. I think he's back north, but Mark, I just got to plug it. I mean, we are down in Florida at Lake Nona. This community is awesome. We have a show where we're live streaming with the help of NAHB student chapter. So even yesterday's show, we live streamed into the classrooms of universities across the entire country, educating them on what we are doing. So it's really cool. And we're going to be going to some really cool places. Maybe we can get up and show what you have done and start educating, because it all starts with our youth. So, all right, I had to throw it in there. I'm having so much fun. All right, moving down the line. Let's see what we got here. Hey, Ben Hershey's in the house. What's happening, Ben? Dave Cooper, great presentation today. Really cool to see how this group is part of those who are transforming housing. I love it. Awesome. Thanks, Ben. Mark, you take this next one right here.
I also want to say hi to Ben. We worked together many years ago. The guy is a genius and very well connected. So thanks for joining us. I'm ready for the next one, brother. Ralph, okay, what do you got here? He asks, what method did you use for anchoring the masonry through the ICF? Oh, all right. Who wants to take that one?
That's a good one. So we had to use thermally broken masonry ties, but we also had to accommodate the mason with the masonry board, which was a bit of a juggle between what the architects wanted to see and what my mason wanted to see. And I've worked with my mason for over a decade, so tried to bring him in early and get that detail worked out. But it's what the trickiest part was not only accommodating his masonry board, so he had a backing to put that stone against and not have the mortar fall back there and have all that mortar net back there in our rain screen, but also bricks are nice and even on the bottom, so your weep holes and your flashing is kind of a piece of cake. When you're doing that natural stone and it's a full stone veneer, we ended up using an EPDM and putting that behind the backer board so that we could have an undulating piece of flashing for those weep holes to come out at the right height. But Ralph, great question. That's always the question I ask when I see.
I love that answer too, because it's first having the experience with that contractor helps, because then you could guide each other through that process. But then making the switch to the EPDM, I think that calls for success.
Very much so. Very much so. All right, here, next question, Mark, is a long one from Jennifer. She has a good question on this, and I'll read this one. Shannon Pendleton, you really are a prefab convert, are you? How are you and Ilka and Angela bringing the hybrid approach of offsite, on-site, and offsite construction together on future builds, or inspiring others to incorporate this strategy on their next project?
Jennifer, thank you. You are reading our minds. So what we all want is a passive house, 2,000 square foot detached single family home for under 400 grand. So everybody can have one, and a lot less than 400 if we can do that too, right? We are trying to do it for Habitat for Humanity, and that's really the goal. So if you're talking about scaling up, prefab is a great tool. And if you're thinking, oh, I'm old school and I kind of like working with my hands, that's not going to change, right? When you're on the job site, the first time you got a lull, or the first time you got a laser level, did you say, oh no, I want to do it the old way, I want to climb up myself, or I want to string it myself? It's just a tool, and it's an amazing tool. So what's really key is the team. The contractors are in the factory putting this stuff together. They're taping the windows in the factory. Contractors aren't going away, okay? They're just using better tools. And then the team is just getting together earlier and looking at the digital twin. So that this is all figured out beforehand. And we solve all our mistakes. And I thought, Ilka, when you were presenting, I'm like, yeah, so we're screen capturing, we're figuring out all these details, we're doing this. The job site's everywhere now, and we're all working without the weather on us. And it's terrific. Everybody gets a hand in. And women really get to determine how the building's built before it even shows up, which is a great way to get women in the field. It's pretty key, Jennifer. Thanks.
Shannon, you know what? There's so many points, and I know, Mark, you're going to jump on it. One, it's always sunny and 70 in the factory. Two, imagine extending the lifetime of your workforce that's in the field. You're not losing jobs. You're going to be doing more jobs. Now you don't have to carry all that heavy equipment. You can have a crane that places and assists that. It's not an additional cost. It's an enabler for you to be better and more productive. Don't get me started. I can go on and on about this stuff. There's so many positive benefits to it. But Mark, I know Mark's itching to say something. I see he leans into his mic. Did you catch him? I got him. Go ahead. You're muted, buddy.
I got that mute. So very happy with Jennifer's comment and how you took it, Shannon. And so it's so simple. Whenever we've done a job, all of us construction professionals from the AEC world, when we're done with the job, we look at it and we say, we could do it different if we had that project to do again. So for those in the field and contractors out there that are looking at those new tools, as Shannon calls it, well, look at this. Our architects and our designers and our manufacturers, they are now building it for us the first time. And their tools are so much better than the tools that they started with. And so since they have better tools, we're fortunate to show off our new tools. So the fact that we all have these fabulous tool belts and we're building things in thin air so we could build them to last and to put our names on them with pride is a blessing. And if you don't embrace it, just wait. Your skepticism will change once you have the opportunity to work on something like this, and you too will become an evangelist.
Yeah,
Mark, I just wanted to say one thing. We were on a call with their new next builder for their next project, who, when he looked at the drawing, said, I could stick build this faster, right? You know, and maybe he was right in the beginning, but now he's a convert and he loves it. So just think about building more of them more often and having really skilled guys, at your disposal in and out of the factory. They show up knowing what to do.
Yeah, well, that's it. You end up with a partner, not a supplier, a partner, and that partner helps you work through everything together. So you're adding to your team versus just buying from the local lumberyard and walking out the door. So those are the benefits. Listen, we are at an hour. We have some more presentation to get through, correct? Yes, right? All right, so let's do a couple more quick we're gonna just real quick clear a couple things out because they were pertinent to some of the things that were going on earlier. Mark, go ahead. I know you got your buddy here.
All right, Greg Ugaldi, first and foremost, thanks for joining us for 49 episodes in a row, brother, and for being a voice to our industry. His comment is reflective of each of you, and he says this is a very impressive group. So
Yeah,
bless your hearts.
that's fun. That's fun when it comes from the top of NAHB. You know, they're one of the biggest lobbyists and protectors of what we do in our industry. So they're the front lines. All right, here we go. Here's another question. We'll do this one, then we're gonna get back to it. Steve Glickman, RACSI, coming to us from LinkedIn. Can you give a rundown of all the software, Revit, for example, and formats, IFC, etc., you used in collaboration from design to fab software in the digital collaboration? So this is a big thing because there's not a one-place solution for people to really get this information. So how you all pulled this together, I'm interested in hearing as well.
Well,
Who would
Steve,
like to
I
take
want to give you the long answer, but the short answer is we had 5 3D models on this project, and I want you to see the one that Steve has in his pocket because that's the digital twin. And when you're a craftsman, you don't use one tool to build a chair, right? So we needed another model. We needed this digital twin. And you also need to see Angela and how she made sure that what we put together was great. So yeah, there were 5 different models on this.
That's a perfect segue. It's a perfect segue. So Steve, get out your pen or pencil or laptop and gear up for the notes from Angela and Steve. And I guess Angela, you're going to take us away.
All right.
Yeah, that sounds good. Thanks. Shannon, are you good to share?
Yeah, the presentation's no longer up. So if you could put that back up, Shannon.
How's that? Sorry, I thought we were going to Steve. My fault. Can you see it?
Yes. Perfect. Great. Okay, so transitioning to the verification piece for just a few minutes. So we like to use this little kind of example reference, what to expect when you're expecting. But it's like so many things in life. It would be great if we had a book to just tell us everything that we need to know about passive house verification, right? But unfortunately, that doesn't exist. And no matter how much you plan, issues are still going to happen. And that's okay. It's usually nothing that we can't clean up, fingers crossed. So I'm going to walk through just a couple things that came up in navigating this project, and I'll speak to kind of what those looked like. So next slide, Shannon, whenever you're ready. So first, it was most of the team's first time working on a FIAS project. So with any new process, if there's a learning curve, and I do want to say with FIAS, there are some common oversights with respect to process and milestones and requirements. And I think that this is something that's really important and not communicated nearly enough. But I know there's a lot of words here on the screen, but it just kind of walks you through general process and milestones. But there are several prerequisites of FIAS, right? And they're kind of like these Matryoshka dolls. Am I saying that right? Like the Russian nesting dolls, right? So it's like, because you have to do this one thing, you also have to do this other thing, et cetera, et cetera. And because we're pursuing passive house, these prereqs aren't difficult to achieve, but we still do need to make sure that they are implemented in the design and construction. So luckily for this project, we were involved early on to review all of these requirements and expectations with the team. And I will say, although there were a few items where the team was like, oh, I had no idea that was a thing. We were able to get them resolved early on so that they didn't have any, so that we didn't have any larger issues down the road. So I guess the takeaway here for folks listening is, if it's your first passive house project, specifically a FIAS project, please talk to your rater. There are several things out there, like, for example, did you know that your HVAC contractor needs to have a certain certification, or that your domestic hot water systems are going to be tested? If you didn't, please go talk to your rater now, or if they're not on board, please get them on board ASAP. Next slide, whenever you're ready, Shannon. Second thing here, as with lots of projects, field changes happen. But it is the job of the rater to verify what is installed is per the design, right? So one of the first things that we observed when we got up for our sub-slab insulation was we had 6 inches of sub-slab insulation installed in the field, but the drawings called for 4 inches. So in coordinating with the team, it was confirmed that there was a design change. The installed condition was supposed to be 6 inches, but we also needed to verify that the WWOOFy model accounted for this change. And in our case, the model really was not affected between 4 inches versus 6 inches of insulation. But, depending on the project, like if you are working on a larger multifamily project, 2 inches, like 2 extra inches of insulation could really mess with your cooling loads. So it's something that you really, really need to be aware of, because it could throw off the whole project. Next slide, Shannon. Okay, so finally moving into our experiences with our blower door testing. So this leaky project, as I like to kind of call it. Okay, so at our first blower door test, once everything was enclosed, we had all of our vapor and air barriers installed. We set up our blower door, and we kind of ran into your typical issues, right? Like leakage around gaskets and ERV penetrations. But we also ran into issues with our ceiling air barrier insulation. And that's that picture on the left-hand side that you're seeing. So for this project, we used a sheet applied SIGA air barrier. And it was adhered to the structure with staples, which is a manufacturer's approved method. However, as you can see on the photo on the screen here, we had several staples kind of missed the structural members, resulting in like all these tiny little leakage points across our entire ceiling membrane. And, we're working with a 10,000 square foot house, right? So, how much leakage this actually contributed to the total overall leakage is kind of difficult to say, but it certainly didn't, it certainly didn't help, right? So that was one thing that we found right off the bat.
The benefit, Angela, the benefit of that is you use the tool, right? The blower door as a tool to find these leaks at this stage. That's the crucial part of this detail that you guys have, is that membrane did that work for 98% of the space. And then that blower door was the tool at the right time. And these details you're showing are lessons that we're all going to come across. And I'm so thankful that you're pointing those out really up close. Dave took the SIGA training, and that blower door is the tool for the success. I love these photos. Thank you.
Yeah.
Oh, awesome.
And I want to add to that with SIGA. SIGA has always been a great supporter of our show, and I did go through their air barrier and house seal training up in New Hampshire, and I have to tell you, education is a world of difference. So if you have a team out there, whether it's SIGA or others, it's one of those moments where I've been a builder, you know, I know what it's like doing Tyvek and putting it on. You don't think those little holes add up. Go to training and all of a sudden a light bulb went off and I'm like, man, have I been a fool? I need to go back to 1,600 houses that we've built and fix some stuff, you know, because you only know what you know. So with that said, you know, a lot of that can be avoided also with training. And we always joke on the show, right, Mark? I think everybody should have a air barrier specialist on site while this is happening. And their only job is to make sure that that's not happening. I love it.
Thanks, Dave and Mark. Yeah, and I mean, obviously, I think this goes without saying, but, you know, for these projects, we're required to have a final blower door test, right? But you need to get in with the blower door early on because we need to find these issues early on because the absolute last thing we want to do is get in at the end of the project and we're not meeting our benchmarks. And then what do? It becomes 10 times more complicated, right? So, so thank you. Yeah, and the last thing that I wanted to point out on this slide here is, you know, in addition to like it's the rater's job to find these issues, right, and report back, but it's also so important to preclude issues as much as possible. So the photo on the bottom right side of the screen, so you can see we have our air barrier installed. And then what was getting installed on top of this air barrier was loose fill insulation. And SIGA actually recommends that you install battens to support the load of that insulation so that when that insulation gets installed, you know, the air barrier is not pulling away from the structure and like completely losing its function. So that was actually something that we saw when we went out for our preliminary blower door, that those battens were not installed. And we did note that and recommend that, and the battens were subsequently installed. So, so that was our first blower door with these issues noted, and we failed. So next slide, Shannon. But that's okay because we kept going.
It's okay.
It's okay.
PH, Angela.
Exactly. But we kept going. We went back, and what we did was we went back and we taped over the staple holes throughout our air barrier, as you can see that Shannon's pointing out. You know, also what's so important is doing IR scans throughout to identify different leakage points, especially in areas where you can't directly access. You know, for this project, we're dealing with higher ceilings in some of the areas and we can't get up there necessarily. The IR gun is like so amazingly helpful. And, you know, we involved the team. You know, when you're dealing with passive house airflows that are so low, leak chasing can kind of become this just like this brain teaser puzzle treasure hunt, like whatever you want to say, whatever you want to call it. It can be like so difficult, but it's also so satisfying when you find all of these leakage points. And I also want to note, you know, I think an important unspoken duty of a rater, I feel, is to help educate the builders. You know, like our Silvergreen team was so awesome. And me and my colleague Nick went around with the team and pointed out all of these things that we were seeing. And it was like, they got it, right? Like as soon as we started explaining to them, they were like, oh yeah, like that makes sense. We get it. We see what you're seeing now. And after a little while, it turned into this like little competition among some of the guys to like see who could find the most holes. So it becomes, you know, even though we were like, what the heck is going on? It became this like really fun and kind of educational piece of the project. So this was our second go around, and we patched up as much as we could. And we failed again, but next slide, we tried again. And this time we went back and this time we were really looking at the smaller details, right? So we went back with more tape on our air barrier, ceiling air barrier. We also went back and applied liquid mass, thank you, Shannon, liquid mastic over the tape, adhering our sub-slab vapor barrier to the ICFs on the lower level of this project, just because those ICFs, and I think Shannon mentioned this earlier, they actually have these like tiny little ribs in them, which are tiny little like pathways for air leakage. So we went over and made sure that that was totally sealed up. And, you know, third time's a charm, I guess, because we finally passed our blower door test. And I will say, you know, it's actually really nice that it took us a couple tries, because it would have been like super boring and uninformative if we passed the first time. So it was, you know, it was like nice in a way that it took us 3 times. Next slide. And then let's see. Oh yeah. So at this point, we feel like we're in really, really great shape and set up for success for our final testing and inspections. And we're excited to deliver, hopefully, a very successful project come this summer. Fingers crossed.
I love this, and I you know, we're at our hour and a half mark, so I know if you guys are with time, we can give it a few more minutes here, but I just want to make sure that we also have an audience out there. There's a couple more questions, but I want you to think about, before we end the show, what is your one thing that each of you took away that you would maybe do different from each of your roles on the next project? Like, what's the learnings of this, right? When you say, well, all the times you failed the, you know, the air blower test, you know, like what will you do differently up front to help people that are looking at this, to save them from making the same mistakes or doing some things that they could do better? So it'd be great to get each of your opinion on that at the end of the show. But what an awesome presentation. You're almost at Mark. They're pretty close to coming to one of our longest shows, and my face hurts from smiling.
I was gonna say, Dave, before we get into people's feedback, can we pass the mic to Steve so we can light this firecracker off?
Yeah, let's do it. You're muted, Steve. There you go.
Hey guys, do you want me to share screen real quick then?
Absolutely.
Yeah, that's right. The digital twin, bring it.
Share screen.
Do I need to stop sharing?
Nope.
I think
No.
you're good. Yeah. Just the digital twin. We've been talking about it this whole
Sharing screen is
time.
easy too much.
Yeah, I don't
I
see
want to
your
make sure I
screen yet,
share the
Steve.
right one. Oh, okay, good. There we go. So you see them
There it's
all?
popping up. Hey, let's bring it in.
Okay, cool.
There you go,
So,
Steve.
all right.
Thank you,
So
Mark.
I'm gonna go really fast, and then if anybody has questions, the white model on the top is there was a question I saw earlier about the software and like how we create this. We call this single integrated manufacturing model. So basically, it's kind of a hub of info. So we're creating a lot of the content, but we're also able to bring in and then send back out content, mostly through IFC file. So this is actually Shannon's Revit file, the white. And the difference, so what we like to tell people, there's the difference between a BIM model, which is this model, obviously simplified in a single texture. But you know, as you can see, this is a very, very high fidelity BIM model. I mean, the detailing is excellent. Inside, it's amazing. But it doesn't have, it's a volumetric model when it comes to structure and systems. So, you know, it doesn't really have framing in it that you would build. And so the difference is that we can't necessarily create what the SIM model without knowing what the design intent is. So the BIM is critical for design intent. And so we can bring in design intent, and sometimes we can use some of the design intent more than just referrals, but a lot of times we'll just rebuild because, you know, the tolerances and planes are different. You know, that's just not, like Revit doesn't need to worry about where the lining of the framing is necessarily to the same level that we do. So we end up creating, here's just another look of, again, the difference between, you know, you can see what an awesome Revit model this is, but, you know, this is the wall, right? That's what you have, and we can't manufacture from that. So we need to create something more like this. So this is just a sim model. I'm just going to kind of blow it apart a little bit. So this is the truss framing. We basically start, sometimes we'll start from CAD drawings. Sometimes we'll grab a section or two. And in this case, we basically modeled out every truss to make sure that, you know, there were some complicated kicks that were kind of creating some crazy joinery. We want to make sure that the geometry, when it lands, is not going to give problems for the carpenter. So we actually will model a lot of times the millwork. And in this case, to make sure all that millwork lands correctly, if you follow that millwork around, there's some pretty high tolerance stuff happening. And then, of course, it also coordinates with some steel, and it coordinates with timber framing. And so we can import and export. We can kind of design content when we need to, or bring it in. I'll show you the MEP in a minute, but just staying on this. Another question I saw was about the Groin Vault. So this geometry for the Groin Vault actually came from Shannon's Revit model, which is awesome. But we needed to coordinate with the company that prefabricated the Groin Vault systems, and we wanted to make sure that they were going to work not only with our panels, which I will also show you, but we actually had to coordinate with the truss guys so that they could make sure that they designed the roof trusses to work. So when it came down to it, we were back and forth with the roof truss company to make sure that we all totally agreed on that geometry and that it would land nicely on our walls. So, you know, if I take that and let's see, this is sort of like our walls if I took the wood fiber insulation off. So what's really nice about this model too is as it develops, we can really navigate. Oh, I didn't answer the one question about software. So we use CAD work. This is all CAD work. And so, you know, what's nice is in this model, as we're building it, we're organizing it, not just for our use, but also for the builder's use. So you can like grab, you know, a kind of material and you can just say, I want to look at, you know, like that material. So that's actually the insulation cavities. If I want to go back and I say, I want to just focus on sheathing, I can grab a piece of sheathing. And now I'm really analyzing very closely exactly what's happening with my sheathing. This was also really helpful. I actually was a lot in the field because at the time I was with the GC that was hired under the GC to kind of deliver the envelope. So what was awesome was to model there's some crazy light deck. So like in here, let's see if I can get that in there. Sorry. Yeah, so there's like, I got to take this off. So you see this? This is light deck. We've never done it before. It's an insulated form. It creates that structural. So there's a beam and a rebar schedule in there, and so there's a light deck spanning right here, in below the garage, and then there's a light deck under here. This is in the passive house envelope. So there was some crazy stuff happening.
Can you give us an idea on size on what those light decks are? Because I don't think people realize how expansive that is.
Yeah.
Well, for the garage, you're at about 24 feet.
Yeah, so these are the forms. This is what they actually look like. And these were, I think that's going to tell me. Yep, 24 foot 4 5/8. And then there was this system out here. And then there's obviously this really complicated rebar schedule. But what was great is that by modeling it, we were able to not only coordinate and make sure that it was all going to work with the panels and with the structural steel, but we were able to actually create some quick trade. We do a lot of trade coordination drawings. So once you have it in the model, you can export some pretty good, you know, like trade coordination drawings. Well, that's okay. This is, that's all right. I won't get into that. What else was I going to show you?
I interrupted you. I want people to understand that I interrupted you, and you took the click of your mouse and you showed us that it was 24 feet, 4 5/8 inches long.
That's
that wasn't
right.
a guess. That wasn't an approximation. That was a specific answer in the middle of this wonderful run through. So brilliant the way you
Mark,
introduced
now imagine you're on the team, the builder's on the call, the subs are on the call. They're talking to Steve, who is a builder. Ilka's an architect. We've got 3 passive house consultants, and everyone is talking about the actual, we're on the job site right now.
Yeah, either on the job site or virtually, right? Because that's what's great is a lot of this actually happens before you've bought a piece of lumber. I was going to real quick just show you the MEP. So this MEP, oops, let me get that off there. This MEP came from Shannon's team with Revision and Shannon, the mechanical engineer. There's some issues that we kind of had to work through, but what's great is, you know, when you have this model, you can navigate through this model very quickly by like activating along like material or group or almost an endless number of layers that you assign to the objects. So that means you can then start to stack things. So like if I say I want to look at this, and I also am interested in how it's what the relationship is with like every piece of spruce pine fir, then I can do this. And now I'm actually looking at MEP only as it relates to spruce pine fir. And I can look at anything I want. And then if I want to bring in more, and I say I'm interested in what it looks like with concrete, then I can add concrete. So you can very quickly kind of create a custom visual. And then what's insane is you can assign data to like ridiculous levels to every single piece, every object. So if I like hit one, you see that data? That's like a scratch in the surface of the kind of data I can apply to that part. And that means when I can apply data, I can export data, and I can export it into a spreadsheet that could be accessed by just about everybody on the team during design and then long after the envelope is complete. So we basically deliver this model with a lot of data attached, and we hand it over to the builder when they're done. And then the other day, I have this awesome picture I was going to show you. I walked into the job trailer for our next project, and the builder said, I want to look at this one structural steel detail that we coordinated with him. I'm like, awesome. So I go into this job trailer, and I almost cried because he had a laptop open with our sim model, and he had already navigated to the detail and pulled up the things that we need to look at. And I'm like, dude, just stop. I'm going to cry right now. So but that's kind of what Ilk and I want. We want this thing to become a user model, not just for us.
So I want to elaborate on this because this digital twin is so important, right? This whole idea of field verify anymore is kind of out the window. The accuracy of what these BIM models and Revit models can do is amazing. But where it comes down to the rubber meeting the road is money in the pocket of developers, builders, people out there. I want to understand, like, from a cost savings perspective, did you have to over order by 20% to cover your amount of materials? Did you have to have additional dumpsters on site? How many change orders did you have on this project using this digital twin? You know, because change orders cost time and money, not only for the builder, but for the customer. I see Shannon there. This is the message we have to deliver, and we got to talk to people's pockets and understand that the efficiencies behind these systems makes up for some of the costs of implementing these types of systems into your process. And this is what people have to understand. So I'm saying that, but you go ahead, Steve. I really tell us how many change orders you had. I already know Shannon.
Well, Shannon is the one that can tell you about the change orders, but I can tell you because before Ilk and I started Holtram full time, you know, she and I were basically the clients, right? We were the people. Right. We were doing this, but we were doing it for our projects. And I can tell you that easily the amount of time that it takes, because you remember, you need a production model of all the parts that are going to be panelized. You need that, right? So you need this type model. So the extra time it takes to then turn it into a sort of a fully inclusive coordinated model which is a known cost, right? Compared to the risk mitigation and the potential change orders and things that could burn your schedule, your material costs, your labor costs, your momentum, it's just impossible. So I can tell you from our personal projects, it's a no-brainer. It easily pays for itself in the first error that you found. And
you know, Steve, when you gave me a couple flashbacks, right, when we were looking at that, because we had to take out a pocket door because of a piece of mechanical that we hadn't coordinated perfectly. And, you know, I've been drawing houses forever, and usually this is happening in the field. we hadn't put the door order yet in, so we didn't have to deal with that. We fixed it in the model. We never ordered that door. I wasn't happy, but you do need the mechanicals in that spot. So we came up with another design solution.
Yeah.
And that's the opportunity that this gives you on a micro scale.
Yeah. Yeah.
That
So
was
I don't know what
fabulous,
else you want to.
Steve. That was
Yeah,
really fabulous,
Yeah.
we could do a part 2 whenever you're ready, because that's just the tip of the iceberg. The detail you showed, from a job costing perspective on the front end, this allows proper pricing.
I think so too. Yeah.
Oh,
You
100%.
know,
100%.
And
Yeah,
for
I'm gonna-
anyone out there that thinks it's just too expensive and they're looking at the house, this isn't what made the house expensive, right? The house was already expensive, and this is what can be applied to affordable building. This is what allows you to scale it up. So that's what we want you to take the lessons learned for. We don't want you to go build, starter castles. We want you to house people who need homes really badly. We've got that national shortage in the housing and the skilled labor. This is a big solution for that.
It is.
The trademark that you guys came up with. I guess the acronym for your trademark is SIM, right?
Mm-hmm.
So everyone learn, right? This is what we do. We learn. So thank you very much, Steve.
Sure.
Shannon,
Thank you so much for letting me be part of this. I wanted to say that I'm super honored to be able to work on projects with these three powerhouses. But it's the information that they bring into what we model that's the gold, right? I mean, if you don't have good information and good design intent and expertise and rater expertise and all that, then the model is just another tool and it's not worth much. But it's a great combination when you have a good team that's open to it. So thanks for letting me hang out with the superpowers here.
Steve, you're one of the good guys. And listen, you can get a prefabber who won't get engaged in design. And you have to send them stuff and they'll build it and it'll show up on site and maybe it won't fit. So garbage in, garbage out. It's a tool.
Oh, there's the one thing I also have to say is I also
amazing.
really want more women on the construction. Really, really.
Steve, I'm telling you, the level of detail. If you go into, and we're going to wrap up the show here, there's 2 more comments we'll put up in a second, but if you go into a lot of the modular manufacturing facilities, there are more women even in these factories, but guess where they're working? They are working on the detailed things. We were talking about this morning in a meeting, that women see stuff before men. In a lot of instances, they can visualize things. They see the smaller details where, I'll manhandle it. It'll get in there, but you'll see the tolerances. So, Steve, I agree with you 100% that we need more women in this industry. I'm a big advocate for it. I know Mark is as well. Well, let's hear. Ben Hershey had another comment, so let's put that comment up. It says, Steve, what you are showing, early interaction of trades into the model, is so very important. Thanks for giving viewers a glimpse of this. Yeah, absolutely. Hey, if you're a GC, guess what? You don't need 100 dumpsters. You may not need any when you do it this way. And that is the key here of the digital twin and on-site. And we got one more comment for a question from Joel Hutchins, but we're going to let's speed answer his question real quick. Mark, you want to read it?
Absolutely. Joel, thank you for being here today. If you all don't know Joel, and Joel, if you don't know these 4 wonderful people, become friends. So he says, great point, Dave Cooper. Who pays for all the front work? Who pays for all the front work? How do you make sure that you don't just move work, effort, and cost from the site to the office? Do you automate some of this design? And how does the file link to IC and manufacturing machinery? He's got all those questions, and Ilka's just smiling, right? Shannon's nodding her head, pointing to Steve, and Angela is just
Yeah,
kidding.
this one's for Ilka for sure.
So beautiful. Go for it.
Okay, so one of the really brilliant things that we always like to point out is that one sim, that model, the sim model, is actually what feeds the machines. So there's not another level. So that's and again, as we said, once you move into prefabrication, you have to have that. You know, you make a decision between prefabrication or not, and as soon as you go down that route, you have to have that model, because nothing else is either meeting the machines or feeding people on a you know, who are working from shop drawings. So there's really you know, and then the whole kind of cost analysis, if prefabrication makes sense or not. I mean, that's a whole nother story, but typically, you know, what you save in efficiency kind of makes up for the cost of having to model things, right?
Can I wanted to start, or I'm sorry, when you're done, Ilka, I want to mention one other thing too about that comment, but go ahead.
Well, now you can talk.
Oh, I'm sorry. Which Ilka said is exactly right, but on this project, there were actually 3 builders. There were 3 builders that bid the project. And I think all 3 bids were super close to each other. So we actually won the bid, not just based on, you know, some of the efficiency of the panelization, but we actually won the bid, you know, fair and square cost wise. And most of the production model that Ilka just explained, like, you need this production model. We add to the production model to create a much more sort of trade inclusive model. That extra part is peanuts compared to the cost of this project. So actually there was, if you look at it that way, compared to the stick built passive house, you know, competitors, there was no added cost.
I love it. I love it. All right, everybody, listen.
Can I say just one more thing, Dave?
Go ahead.
We do do mentors, and I know all 3 of us look up to all the other Shiros in Passive House. Katrin, Lisa White, Chris Benedict, Prudence, Lois Arena, my friend Catherine Pass. They paved the way, made it easier for us, and we want to pave the way and make it easier for the next girl.
Well, speaking of Prudence, don't we
Who's coming on your show?
She's guest number 50 with a PH next Friday. And that acknowledgement, Shannon, is necessary. We've all had people touch our lives. We're here to remove the skepticism, bring forth collaboration so we can have more evangelists. And bless your hearts, Ilka, Angela, Steve, and Shannon. I'm thrilled for today. And I hope our audience shares this presentation with the architects, manufacturers, suppliers, and future clients, future with a PH. And we'll bless your hearts. Thank you.
Love it. All right. So listen, we're going to wrap it up, everybody. So thank you, everybody, for being on. Monday, welcome back, Greg Ugaldi, 1 p.m. Greg Ugaldi will be on the show this Monday. We will be talking about what is happening in the housing industry from the top, which we always love doing. And tomorrow I'm trying, you might catch me on an autonomous vehicle riding around Lake Nona, drinking my coffee on Coffee with Dave. We do Coffee with Dave 9-ish in the morning, depends on what's happening with kids and everything else. But we're looking forward to it. Steve, Shannon, Angela, Ilka, Mark, you guys are awesome. Don't go anywhere. We'll come back to you right after the outro. Mark, once again, man, you're a rock star, and the rest of you, you're doing amazing stuff. We'll see you next time. Bye now.